Hey guys, hope you are doing great. Maxim here, and today I want to explain you why I was missing for such a long time, and also explain to you what I've been learning and trying to implement all this time, so that you don't need to spend that much of your time and effort in order to get it working. So today we'll cover encryption and decryption process. We'll cover exactly the server-side encryption decryption, and I will show you first the models that I was trying to create, so the system designs that I was trying to implement, why it failed, why it's not good, and also the approach that I took literally yesterday and it finally worked. So now I have encryption and decryption system working, and I will show you also how I did it. Yeah, so let's first dive into this small flowchart that I created for you. By the way, this all flows are for medical cards that GitHub repository you can check under this video in the description. So when the user logs in, he needs to set up encryption password. After that, the salt is automatically generated and stored in the supervised database. After that, we are fetching the IndexedDB. By the way, for this project I am using IndexedDB. I will explain later in some other video why I chose this, but you just need to know that I use it. So we have client-side storage. If it's the first time for user to log in, there is no data yet. So it will call a Python script. What Python script does is it gets the Gmail access tokens that we get from you when you are authenticating. We are going inside of your inbox and scanning through all the emails to see the emails that are related to blood test data. Then we fetch those emails, we process it with an LLM agent, and yes, we are getting the data output in a JSON format, which is a list of dictionaries. And then I wanted to encrypt it right here in my Python script, and then pass to the front end, where I would actually put it in the IndexedDB with these interfaces, yeah, or type. So here is my encrypted blood test result table, and here is the encrypted file table. Yeah, you can take a look at this. So up until this point, it was amazing. Everything was working fine. So now we are going to derive the key using, I always forget how this algorithm is called, but the standard stuff PKDB2 something to derive the key. And it was also great, right? And then we are going to the decryption process. And this, by the way, so as you see here, we are already in the front end, yeah? So I was trying to decrypt it right here. And this is where it was failing. And I was trying to see pretty much everything I can. I was putting so much logs, so much error handling, all the stuff, inspecting why it's failing. I was changing the encoding modes, changing the IV lengths, experimenting with it, but it was not the problem. So the problem is that I was mixing up two different terms, right? So let's discuss them right here. Here we have encryption in transit, and we also have encryption at rest. And don't get me wrong, before I started doing it, I obviously watched some tutorials, so I knew that these are two different, absolutely two different things, right? But then I thought, well, how cool it would be that I can actually do here my server, and here will be my client, right? So yeah, let's put client. And how cool it would be that even though I have SSL right here that is protecting the data transit, SSL, I said how cool it would be that I can encrypt data here, pass it with an SSL, but just so that it's encrypted, and then decrypt it right here. I said it will be double secure, but at the end of the day it was just double hard and it didn't work. After joining a call with some developer community, they explained to me that it's not how the things are done, and that I should rely on the security of SSL or TLS to protect the data in transit and just focus on the encryption decryption logic for data at rest. And that's exactly what I did, and it worked out. So right now I will show you the new way of doing things, how I designed it, and show you also the code so that you can follow along, right? So let's go. We start right here. And I'm sorry for the chart, maybe it's not that cool looking as a Razer IO, but I generated it with Claude while giving it instructions and then just exported it in Mermaid Live. but you'll get my point. So we start right here, and we start with user key generation and storage. So let's look into the code. Let's look into the code. And as you see, the first step here is we generate user key using a crypto library for Node.js, random byte 32 to string hex. Yeah, so we are encoding it. We are generating the user key, and now we are also encrypting user key using the master key. So I also have here a master key that I save in my .env, which will be very secure. I will not show it to you, but you just need to know that I have a master key. Now we encrypted it, and we store the encrypted user key in Supabase database in my user table. So now, when we try to encrypt the data, we are asking the Supabase for the user encryption key. We are retrieving it. We are decrypting the user key. We are generating salt and IV. We derive the key from the user key, and only then we can encrypt the data. So it can be a little bit complicated right now, but let's look into the code. So right here you see that I'm using IV of the length 16 bytes. I'm also using salt for the key derivation process, and I'm using iterations of 100,000. So here you can see that we are deriving the key using this pbkdf2sync algorithm, which is super cool. And this is how we are encrypting the data, right? So you can see we are having the user key, which we are decrypting with the steps that I just showed you. We are having the salt that we just generated. We having the derived key using this salt. We are having the IV that we just generated. Then we are using the create cipher using this algorithm, derived key, and IV. We are processing it, and then we are returning salt, which is encoded, IV encoded, and encrypted data. Okay, and this exactly we store in the index.db. So let's look first, right? So encrypt data, we combine salt, IV, encrypted data, as I just showed you, and we store the combined encrypted data in index.db. Let me actually, can I show you how it looks? Let's see. Let's see. Obviously, like I still need to fix like a lot of stuff, but the encryption decryption process is working, trust me. So here I get it. We get the data, and here you can see that it's some sort of encrypted data, right? Perfect. So now we are storing combined encrypted data in index.db. We have blood test results and attachments, but whatever. And important point is that we are storing pretty much everything separated by this semicolon, yeah? So we split them. There are also different approaches of how you can do it. You can, like what I have seen a lot that people do is just store, for example, IV and salt in their Supabase, or even here on the index.db, but in separate like rows. And they're reusing the same salt and IV over and over again. What I do here to make it extra secure, because I'm working with medical data, I'm actually regenerating IV and salt for each operation. Yeah, so there is literally no way you can hack me. So now let's see the decryption process. So we are getting our data decryption request. We are retrieving the encrypted data from index.db and passing it back to the server. Yeah. So if you don't know, index.db is a client-side storage, right? So how the system works, let me also like share you just here, because I think I just like erase area, so I want to show you. Yeah. So let's have again our server and client. We'll have server. Actually, yeah, we have server. Then what? We have our client, right? So let's do. So we are having our server. We are having our client. And let's see, we have our index.db, we are having it right here. And how the system works. So let's also see the Python script. Let's do like Python script here. Python, and this will be server side, but it will be Next.js TypeScript. So we are getting the data passed from our Python script to Next.js TypeScript server side. Here we are having the data encrypted. Encrypt. Then the encrypted data is passed to the client and stored in the IndexedDB. So now if we want to decrypt the data, we need to get the data from the IndexedDB to our decrypt. So we are getting it like, let's do it somehow like this. Yeah, perfect. We are getting the data from IndexedDB passed to our decrypt, which is again on our Next.js TypeScript server. This is how it currently works. Let's get back to the diagram. So we retrieve encrypted user key from Supabase, we decrypt user key, we split the encrypted data into salt, IV, and encrypted content. So as I said here, right, we have it stored like this, using these semicolons as separator, so we can directly split it into salt, IV, and encrypted data. And we are using salt for key derivation, we are using IV for the further processing, yeah, for the encryption, for the decryption of the data. We derive the key from user key and salt, and we decrypt the data from encrypted content and IV and the master key, and we return decrypted data to client so that we can show it on the dashboard page. This is how it works. Let's again look at the code. We derive the key with our this algorithm that I really like, with 100,000 iterations and salt of 16. We are also generating the key, as I said you at the very beginning. Here is how we are encrypting the user key, so we have in our salts, here is the logic with key derivation, so master key and salt, this is for master key. Then we also have in the IV, here is how we are encrypting the key using this algorithm, derived key and IV. And yeah, here is how we store it, yeah, so we have salt, IV, and encrypted. Here is how we decrypt the user key, here is how we encrypt the data, here is how we decrypt the data. I will actually put it to you in a separate GitHub repository that you can also check, as well with this diagram that you can follow along. And I hope this video was useful, and I hope that it will provide some clearness for you to how to design the encryption system in your application, because I really had hard time understanding all this, but now it works. Actually, let me show you that it works. Yeah, we are having here the data, we are encrypting the blood test, fetching user data fetched successfully, attempting to decrypt, and we are seeing that decryption completed successfully, and a sample of decrypted data. So I'm really happy with that. I'm very glad I finally did it, and right now I hope I will not struggle for such a long time with any other task. So you can await a new video in around 3 days, and the next video will definitely be about IndexedDB and the use cases where you need to use it and why I chose it for the medical card app. So thank you very much, and have a great day.